Would we even notice if 3i Atlas smashed into Jupiter? What are the plans for the next generation space stations? Is it okay that most successful space corporations are run by billionaires? And Q&A Plus, what is a Thorne Zytko object? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Mad Million, if 3i Atlas was somehow able to smash into Jupiter, would we notice anything? So we have an example of something crashing into Jupiter, and it was much smaller. It was a comet. So Comet Shoemaker-Levy 9 was discovered in 1993, and it's a comet that's 1.8 kilometers across, and it got too close to Jupiter, got torn into a bunch of pieces, and then those pieces splatted into the surface of Jupiter in 1994. Unfortunately, we had the Hubble Space Telescope at the time and other Earth-based telescopes, and we were able to look at Jupiter as the collisions, like they happened on the far side. And so as Jupiter kind of rotated around, we could see the bruises that were left by this crashing into Jupiter. And we could definitely see them. When you think about it, like it was a 1.8 kilometer object that had been broken into smaller pieces, and those had impacted. 3i Atlas is 10 kilometers across, so it is much bigger. So it will leave a much bigger bruise. And there are occasional times where astronomers have detected smaller objects crashing into Jupiter. You get a flash. Sometimes you've seen little bruises on Jupiter. So yeah, it would cause a bruise. It wouldn't last long, like a couple of rotations and the thing would be gone again, but we would definitely see it briefly. And it was an amazing opportunity for science when you think about it, right? Like what we see of Jupiter is really just the cloud tops. We're just seeing the outer layer of the atmosphere of Jupiter. But when this object went in, it essentially excavated a hole in the atmosphere briefly, sort of caused gases that were deeper down to be revealed to the surface. And it was a great opportunity for scientists to be able to study it. And so, to have something 10 kilometers across crash in, that would be amazing. Pura Vida Hoser. What's your bet on the design of the next space station? Do you think it'll start going up before the deorbit of the ISS? How much will they reuse? So right now, the United States has no plans to build a space station. So by 2030, it's expected that the International Space Station will be deorbited. The Russians have said that they're going to extract their portion of the station. And so it'll just be the American version that's going to re-enter the Earth's atmosphere. Many people are skeptical. I am skeptical that the Russians are actually going to be able to pull this off and that probably the whole thing is going to come down. The follow-on space station that the United States was planning to build was called the Lunar Gateway. And this is going to be a space station that was going to be in a halo orbit around the moon, sort of essentially like gravitationally a halfway point between the Earth and the moon. Not an actual physical halfway point. And so you would see the Artemis missions using the gateway as a way to make trips to the moon more reusable. So you would fly to the gateway, astronauts would set up on the gateway, and then they would fly from the gateway down to the moon and then back. But under the current administration, it really looks like the gateway is being canceled, even though a lot of the parts have been built. So whether or not that will ever be actually completed and actually launched is unknown. And there won't be a space station. So you're going to have to look to other countries to build space stations or private groups. So obviously the Chinese have their space station and they're planning to expand and extend it, bring on more partners to be able to have more people on board. And then there's a bunch of private companies. Vast is one that is working on a pretty cool idea for a space station. It's very modular. The pieces fit together and you can sort of see how they would just keep expanding it as they get more funding. But that depends on there being a business. And I think, it's possible that NASA would be a really good customer for something like a private space station, just in the same way that they've been a good customer for a privately built space capsule that gets you to and from the International Space Station, that they are a good customer for privately built spacecraft that will carry scientific instruments to the moon. You can imagine that they would pay some commercial partner to be able to send their astronauts up to some station component where they can do a bunch of science experiments for NASA, but not have to sort of foot the entire bill of launching the station and manage its operation. So I think that that's a model that NASA has tested so far and seems to work. But right now, there are no concrete plans. There just aren't. A bunch of people say they're going to do this. There are plans, there are press releases, but I haven't seen any players who are putting serious money into this who are, are absolutely guaranteed in the way that, say, NASA saying, we're going to build the space station are. Indoor teacher. All seriousness, what are the odds that a flat Earth actually exists? Somewhere out there is a flat discus planet. So the problem is that the gravity of any object will try to pull it into a sphere. And so this is a thing called the hydrostatic equilibrium. And generally you will get hydrostatic equilibrium on any object that's bigger than a couple of 100 kilometers across. So a large asteroid, a moon of Saturn or Jupiter, you're going to get it pulling itself into a sphere. The moon is several thousand kilometers across, and so it has absolutely pulled itself into a sphere. So no, you can't get a flat planet. If you have a flat discus planet, it will just pull itself into a sphere again. Jonathan Chamberlain, how do we know that the sun has 4.5 billion years left before it turns into a red giant? So we can observe many different stars out there and get a sense of the life cycle of a main sequence star, of which our sun is an example. And there's a sort of well-known categorization system called the Hertzsprung-Russell diagram, and sort of shows the sort of phases that different stars go through when they're in their main sequence phase, and then they can be off sequence when they turn into red giants and so on. But the gist is that, we can see examples of billions of stars at all different masses and all different phases of their lives. And astronomers have various ways that they can actually calculate and see how old various stars are. They can look at globular clusters, which are pretty much as old as the universe itself. And they can see sort of what is the most massive stars that we see in the globular cluster. And then that tells us, how long will stars live, right? We don't see the more massive stars in these clusters. They've long since died. You can actually sort of calculate that. We can see examples of star clusters and see where there are massive stars that are going through the end phases of life, turning into red giants. We know all the stars formed at roughly the same time. So we just have tons and tons of samples to be able to confirm. And then we have a pretty good understanding of how the internal processes of stars work, how long it takes them to run through the fuel in their core before they switch to helium burning, turn into this red giant phase of their life cycle. So, how do you know that you're going to grow old, right? And how long you generally have to live? Well, you're surrounded by human beings at all different phases of their life cycle. And you know how old human beings tend to live because we've seen plenty of examples of humans dying. And so it's the same thing with stars. It's time to shout out our new patrons at the $5 level and above. Rick VA3DSO, Rick Nichols, Sherry Hackett, Evan Sales, Top Clean, Yanis Akulovs, Oleg Manilov, Dottie Straight, Lillian Tchaikovsky, and Richard St. Clair. Join our community at patreon.com/universe today. Ayusha Growell, is there a world where local astrophotographers can get paid to do astrophotography? So there are astrophotographers who make a living from their astrophotography. They're selling prints, usually, or they are selling the rights to their photography for books that are about space and astronomy, or they're selling their photos for the rights for documentaries and things like that. I don't know what the market is like today. So when we did our book on astronomy, part of the deal that I negotiated with the publisher was that I would be able to go and hire a whole bunch of astrophotographers and pay them money to print their pictures in the book. And so I had a really great community of astrophotographers that I was working with. And so I was able to reach out, and we paid to have the really cool picture on the cover. And then we paid to, I think we ended up getting 80 or 90 pictures inside the book, which you will have never seen before, which was great. It felt really satisfying for us to be able to go and give work to astrophotographers. And so like there are a couple of astrophotographers, like a handful. I think, some of them have galleries and like in Las Vegas and things like that. And so some have Patreons that you can follow, and there's like a subclass, which is the people who are taking images of rocket launches. There's a few of them who are able to turn that into a career, but it's a long shot. There's not a lot of work in it. And so, you've got a lot of people who do this for free, who do this for fun. So, if you're looking to make a career being an astrophotographer, good luck. I don't know if it's going to really pay off, but I mean, who knows? I mean, I made a career writing about space and astronomy and then turned that into podcasting about space astronomy and doing videos about space and astronomy. So anything's possible, I guess. Indoor teacher, how do you feel about Elon Musk and his impact on space travel? Him and any other rich space tycoon? Do you think they're too rich, or should they be able to continue to expand? I'm ambivalent about the various billionaires building their spaceship companies. I used to be a lot more enthusiastic about it and have sort of gotten a little more jaded over time. So what do I think? So just in general, imagine you just have your generic billionaire who is obsessed with space and wants to take their money and turn that into rocket technology. I think that's fine. I think that's good. I think, as a fan of space, as a fan of space exploration, I would like to see more missions, more exploration of the solar system. I'd like to see us use space better. I'd like to see a base on the moon. I'd like to see a base on Mars. I'd like to see, humans set foot on various worlds around the solar system. And that's going to take rockets. It's going to take hardware. It's going to take technology. It's going to take a lot of development and investment. And there's only so much of that the governments are willing to do. NASA, ESA, JAXA, the Chinese Space Agency. And if private companies are looking to step up and have a way to develop a business model that will make that sustainable, then I think that's a perfectly viable business, right? We didn't have a problem with United Launch Alliance building rockets, the Deltas and the Atlases and so on. And so SpaceX has dramatically decreased the cost of rockets. They've developed and advanced the technology of reusable rocketry. And now it's turned into a gigantic business. And so, it's sort of self-sustaining at this point. We're waiting to see what happens with Blue Origin with Jeff Bezos. But I think they are transportation companies. And the sort of amount of initial investments that's required to create a new transportation company that is going to space is huge. And rocket companies go out of business. That's mainly what they have done in the history of humanity. Space exploration companies, rocket companies have just gone out of business. And there's a laundry list of companies that have gone out of business. But SpaceX was the one that was able to pull it off. So I think on that front, I think they're fine. Now, there are externalities that these companies are putting on the planet in society that are not being properly factored into their business models. Environmental issues, light pollution, pollution for radio telescopes, space debris, cleaning up space debris. There are all of these issues. And, a lot of the times, as with any new industry, the externalities aren't properly priced in. And then we realize what they are. And generally, it's the governments that tend to have to clean this up or pay to have this cleaned up or whatever. So if, I would prefer more sort of regulation and time was spent making sure that the externalities were properly factored into the companies before they sort of filled the sky with 100,000 satellites, because, that's going to be not great for astronomy when these mega constellations get complete. But that doesn't require a billionaire, right? I think you could have just a company that is run by a bunch of shareholders, no billionaires involved. You may not even know the name of the person that's running the company. It just happens to be that two of the big space exploration companies were run by billionaires. So I kind of don't see that being a factor. It just happens to be how this played out this time. The bunny lever. Any idea of how large a telescope could fit in the Starship? So the fairing width of Starship is 9 meters. And so you could put a telescope inside, like it wouldn't be 9 meters, but maybe it would be 8 meters. And so think about a telescope that has no folding telescope parts, like say the Herschel telescope or the Hubble Space Telescope, right? Hubble is 2.4 meters across. So you can have a telescope that is 8 meters across, which would be bigger than James Webb. James Webb is 6.5 meters across. And you wouldn't have to build this complicated folding telescope. You could take a telescope that is about as big as the Gemini North, the Gemini South, and just put it inside a Starship and launch it in one go. Now, if you built a folding telescope like James Webb, then you could probably go to 15 meters, 20 meters, probably even bigger if you're willing to spend an amount to have it folding. So 8 meters if you didn't fold your telescope, much bigger if you had it able to fold. David VA, would you prefer that we find aliens first or that they find us first? I would prefer that we find aliens first. If the aliens found us, then we wouldn't be able to have the introductions on our own terms when we felt like we were ready and we felt like we had sort of understood them a bit. So it would be best if we detected their presence, detected their signals, were able to try and decode their language, be able to understand them better, get a sense of who it is that we're dealing with. But if they just show up and then introduce themselves, anyone who can actually make it here is sort of vaguely threatening, we would have to consider it a risk for sure. So no, I would love for us to be able to very passively detect the presence of another civilization before they find us. And then we can just try to plan out what we want to do about that. Nephilim, can you explain a Thorne-Zytko object? Sure, I can take a crack at it. So a Thorne-Zytko object is a theorized object where you have a neutron star ends up inside a red dwarf, and it was sort of theorized by a couple of researchers by the names of Kip Thorne, obviously classic, and Anna Zytko, and this was actually back in the 70s. And they sort of made these predictions that what you might see when you get this weird combination, that you might get like some kind of drag between the neutron star and the sort of layers of the red giant, and that would sort of change the characteristics of the supernova when the red giant goes off. And a lot of the most massive stars are in multiple star systems. You've probably heard this saying that most stars are in multiple star systems, and that's not actually true. The types of stars that we can see with our eyes, stars like our sun, stars that are much larger than the sun, those tend to be in binary, trinary, multiple star systems. Red dwarfs are the most common kind of star, and they tend to be solo. So in fact, most stars are in single star systems, but the big stars are in multiple star systems. And so you will get, when you have two giant stars in orbit around each other, one of them will detonate as a supernova and turn into a neutron star. And then the other one will detonate in its own good time and probably go through this red supergiant phase. And you can end up with a neutron star inside the red giant star. Now, this has never actually been seen, although there was a supernova, or it's a gamma ray burst, that was seen about a year ago and sort of had the characteristics that could be one of these objects. That, it appears that like a neutron star or a black hole fell into the atmosphere, or the surface of another star. And so they saw this sort of really strange characteristic, and I forget the exact sort of signal that they saw in the composition of the supernova as it went off, but it was like it had never been seen before, super rare. And so they think that there was some kind of interaction where a neutron star was inside the envelope of a red giant star. All right, those are all the questions we had this week. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live show. We record the live show every Monday. It's a 2-hour-long question answer extravaganza. And the next one is going to be for the European time. So it's going to be on Monday, January 19th at 8 a.m. Pacific time, which translates into early evening in Europe. So join live. There'll be an event here on the channel if you want to come and join. Now, I'm going to remind you about our upcoming patrons question show. But first, I would like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradorn, Chuck Hawkins, Commander Bielek, Cy Nelson, Dark Finger, David Gilton, and David Matz, Evan Pro, Greg Feely, James Clark, Jerry Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Bach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Farley Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldebor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So you're watching one of the question shows that we publish here on the channel, and this comes from the 2-hour-long live question show that we do every Monday. But we do another question show, and that is the Patrons question show. And that one is done once a month around the 15th of the month. And so at the time that you're watching this, we will be wrapping up the previous month's question show, and we will be getting ready to put out the call for the coming month, the question show for January. So, the question shows that we do for the patrons is a little more specialized. These are the people who are such fans of space exploration that they are our patrons. And so the questions are terrific. They require a lot of work by me and Anton. They require math, they require research. I sometimes have to ask experts for some answers to be able to give a good and accurate answer. And so if you feel like the questions that you're watching and these shows are feeling like you kind of know the answers, it's sort of like the general public, and this is their understanding of space and astronomy. But there is another level, and those are the people who ask the questions on the Patrons Question Show. Now you can come and join our Patreon for just like as low as $3 a month. And when you do, then you will get access to not only be able to ask questions for the Patrons Question Show, listen to all of the past question shows, but you also get access to the overtime episodes that we do every week. So you get a lot more content from the Universe Today team. And you support our work, allowing us to be ad-free, AI-free, completely produced by human beings for human beings. Everything we do is Creative Commons 4.0. You're free to share it wherever you like. We try to make as much content and be the most dedicated, best space news reporting team that we can. So if you want to join, go to patreon.com/Universe Today. You'll see the call for the new questions soon. And hopefully I look forward to even more questions. All right, we'll see you next time.